Hi, I'm Elaine. Welcome to my podcast channel. Hello, Mr. Mazur. How are you today?
I'm good.
Would you like to introduce your institution and what you are studying right now, specifically in the math field and in general?
Briefly, I'm at Harvard. I've been at Harvard for a while, and I teach and I do research. And the research I do at the moment is in number theory, solutions of polynomial equations. How many are there? What is their structure? What one can one say about the interesting questions that they produce, or what can we say about the structure of number
Hmm.
from this vantage point?
Yeah, for sure. And once I looked into your videos and then math videos. So I noticed that you did some studies in knot theory. Could you tell us about something about knot theory and how it relates to number theory?
Well, it's very hard to actually do that, but there is a very striking analogy that I use to move from being interested in knots and topology and low dimensional manifolds and the Euclidean space and its geometry to the theory of numbers. And the analogy is something that I can only explain on a technical level, but it can be expressed as an English sentence.
Hmm.
Namely, prime numbers are like knots.
Oh, interesting.
Now, that sounds bizarre, but if you take it from the right vantage point, it turns out to be quite a natural analogy and a fruitful one, at least for me, because I moved from one subject, knot theory, to number theory, uh, helped very much by this analogy.
Mhm. Yeah, so there's always connections between different math fields. Like can always connect different ideas, I would say. It's like knowledge transfer. Yeah.
Or analogies. Fruitful analogies that make an intuition in one subject useful in another subject, and the intuition in that other subject useful in that first subject. For example, everyone knows, I think, from just high school uh, curriculum, that there is a subject called analytic geometry.
Yeah.
Now, analytic is a geometry. Analytic is an adjective in that phrase, analytic geometry. But it is a field of its own. Analysis and geometry are two fields. They seem to have nothing much to do with each other. Geometry has to do with pictures. Analysis has to do with equations or formulas, and yet analytic geometry brings them together.
Hmm.
And not only brings them together, but allows the intuition of geometry to play a role in analysis, and allows the intuition of equations and analysis to play a role in this visual subject, geometry. The
Yeah.
creator of analytic, well, one of the many creators of analytic geometry is Rene Descartes, and he said it corrects the defects of each subject.
Yeah, philosophical. It's like this. I think math is really philosophical and spiritual sometimes. I've also heard of there was a debate between geometry, geometrical expression of mathematical ideas versus algebraic expression. So there are people who think that in order to refine your mathematical communication, you have to, I think some people argue that using geometry, you can express your ideas more clearly and logically compared to just writing algebra. I'm not sure if that's true, but it's like a different ways of expression. But of course, geometry is super helpful, especially Euclidean geometry, even though it's super outdated right now. Like a lot of people think that Euclidean geometry,
Outdated? No, it is not outdated.
yeah, but it's so like helpful for us. We just need to use it. We still need to learn how to draw circles and shapes and construct different triangles in a circle using Euclidean geometry, or draw maybe a bisection or something like that. Yeah. So you must have um PhD students, undergrads. So how do you teach them, like, on a regular basis? Like, do you teach them kind of differently according to different math routines?
You teach them differently according to different people. That is, say,
Mhm.
it's a personal relationship between a teacher, a math teacher, or any teacher and a student. And of course, you teach differently because you're teaching a different person as you uh, move from teaching one student to another. So yes, differently.
Mhm. So I mean, do you examine their personalities and characteristics, and then you teach them differently according to how they work?
Not, not in that way. I mean, I would say uh, they might generate a question, and the type of question that they generate might suggest that we, me and the student, investigate something in one direction, and if they ask the question in a completely different way, we would investigate in a different direction. We would have a conversation rather than that I would have an approach that I would make to pose my problems to any uh, any student, no matter who the student is.
Yeah, for sure. I think that is a really, really good way to teach different students at different levels and ages.
Well,
Um,
different people that could be the same level in some sense, and the same age, but
yeah.
they're different.
So I'm just really curious. What was your youngest student in your class? Do you have like a record, like your youngest, maybe someone who's only very young and that person attended your PhD class and something like that happens?
It's nothing comes to mind specifically my youngest students. So, but something does come to mind.
Mhm,
Not my youngest student, but I have a friend. Well, uh, I had a friend. He died a
mhm.
year ago. Very close old friend, and you can
Mhm.
look him up on YouTube. I'm sure his name is Bob Kaplan or Robert Kaplan.
I actually heard of that name. It's so very, very familiar, actually.
Okay, and he ran things he called the math circles.
Mhm.
They still exist,
Yeah.
and in fact, Mira Bernstein is part of one part of her uh, activities is a math circle, which is in the style of Robert Kaplan's math circle.
Mhm.
And I'll give you an example that I think is quite inspiring and conforms to your question about youngest students.
Okay. Sure.
Because he would have the math circles consisted of after school activities,
Yeah.
having nothing to do with any particular school, there would just be a bunch of young students, children. He would have a math circle of, say, 4 to 6 year olds, or 4 to 7 year olds,
Mhm.
or 7 to 8 year olds, or 7 to 10 year olds, or 10 to 14. 4 to 14 year olds is the full gamut. But
Mhm.
any particular class that he would have a cluster of ages. 4 to 6, I think, is one. So
Mhm.
he would go into this 4 to 6, maybe 4 to 7. He would go into this classroom. There'd be a blackboard. It's the first time he would go in, and he'd begin to write 1, 2, 3, 5, 6, 7. At that point,
Yep.
a kid would say, "You forgot 4." And he would say, "Oh, yeah, I forgot 4." So he would erase a little space to give himself a 4 between his 3 and his 5. He said, "Of course, there's a 4 between 3 and 5." And he would write his 4 between 3 and 5 and say, "But there's no number between 4 and 5." And some kid would say, "Well, I'm 4.5." He would hit his head again and say, "Oh, yes, you're right." He would again erase the blackboard, make space for his 4.5, and he would keep going by a series of blunders
Mhm.
to have the children begin to fill in number lines. And then the question is, what if you subtract 5 from 4? What does that mean? And they would develop vocabulary for what it means. So what we call negative numbers, and it depended upon the class, what they would call it, because it'd be their term.
Mhm.
If I remember right, one class called the negative numbers kangaroo numbers, because you jump backwards.
Yep.
And the number line would get filled up by successive blunders that he would make and corrections that the students would make. So that's a real way of inspiring young minds to produce mathematics. It's not
Yeah.
learning mathematics, it's actually producing it by
Mhm.
uh, uh, answering a question and following one's curiosity.
Yeah, so regarding what you mentioned of math, how I totally agree. We have to inspire creativity by making younger students maybe find a way. Like they have to be more excited and they have to be creative as well. And then we have to produce math instead of being absorbing the knowledge. So, do you
Right.
think math is a language in a way that is humanly constructed, or do you think it's a spiritual existence?
Well, I'm not going to distinguish between one and the other. I don't see why they aren't both. But uh, the other thing I want to say is, following the Robert Kaplan math circle, you can go on YouTube and
Hmm.
see him give such a class, not of the sort I gave, but it's geometry rather than numbers,
Hmm.
where he would he went into it was a slightly older uh, class, and he went into the class, and first time blackboard, he said, "We're going to talk about the circle," and he draws a square. Some child said, "That's not a circle." And he looks at it and said, "Well, why not?" So, well, a circle doesn't have corners, and so he smooths out the corners. So, yeah, how about that? And they keep working on him, you know,
Yeah.
to organize this circle until finally some child is totally exasperated, and she says, "Look, here's a circle. If you there's a point, so that no matter where you look from that point,
Uh-huh. Oh,
uh,
the
you
distances
find
between the
a
point
point
should
of
be
the circle, and they're all the same distance from
yeah.
the point." Okay, so now you after this little interview, go to Euclid's Geometry, book
Mhm,
one, and look for the definition of circle. Yeah.
mhm,
And it's not any more cogent than that definition.
hmm.
In fact, I prefer that definition.
Yeah, yeah, I mean, it's all simplicity, and I find that through his method, I really, like his method. One reason for that is because it really emphasizes mathematical precision, and then you have to be precise when you define something. You can't make a 1 equal to 2 or a circle into a square because they're so different things, and you have to be precise when you um, talk about these mathematical figures or shapes. So I think it's really important. Yeah. What
I would
was
actually, I would draw another lesson from that,
yeah.
and it is rather that it's best to start off from something imprecise and work your way precise. Or
um,
work your way to whatever it is you find yourself being drawn to.
yeah. So when you talk about we starting from something that is imprecise, do you mean when we want to develop a new theorem, we have to establish a false statement first and then work
We
our way?
don't have to. We don't have to, but
Mhm,
we shouldn't be reluctant to.
mhm.
Beginnings are beginnings, and you begin where you feel is natural to begin, and then if you um, if you pursue it appropriately with the right spirit, you'll you'll get somewhere.
Yeah, so, how do you personally come up with your own theorem? What is your, process of deducing something or coming up with a theorem?
Curiosity
Mhm,
that there should be there should be an explanation that's missing. That and I would like to find that explanation. I would like to explain something to me that seems to beg for an explanation. It's, if you needed an English sentence that I'm happy with as a way of pursuing mathematics, that's one.
mhm. Yeah, I totally agree. I think it all starts from curiosity and also, grit and
Persistence. Yeah.
persevere yeah, persistence too. Yeah, for sure. Could you
And
also
being respectful to yourself,
yeah,
that
for sure.
your intuitions, uh, and to your um, desire to understand. And that's that's what will propel you.
Mhm. So I looked into your video and I saw that you also teach your granddaughter mathematics too. So how do you teach her mathematics? Do you get her interested from drawing numbers? out and then drawing a square
No,
and then or whatever?
oh, no, I mean, it's more part of our I I I I can't in a sentence give you a philosophy of how I do, how we interact, because we do interact, but
Mhm.
it is so specific to us that I don't think it would help much.
Oh, yeah, for sure. Yeah, I guess teaching different kids
Mhm.
mathematics always differ and
Yeah.
for sure. What do you think is the most, um, special part of the Harvard math curriculum or program?
Well, you mean that there should be a particular aspect of the Harvard program?
Mhm.
I would say one of the great things about Harvard is not its program, but it's just its community.
Yeah.
It has a congeniality. There's something called the math table, which
Mhm.
really works as an, a way of explaining in simple, um, attractive, exciting, enticing terms mathematical ideas, and also gives people practice to do that.
Mhm.
It's as much training of the people who go to the math table to try to understand, for example, what does it mean for um, uh, um, a structure to be maximal in one direction or another, uh, as it is for the presenter to try to figure out what does it mean to
Mhm.
present something in a comprehensible way. So
Mhm.
there's the math table, but there are many other things. For example, there used to be, there still is, but it may have uh, changed a tiny bit. But there used to be something called the Basic Notions Seminar.
Yeah, cool.
The Basic Notions Seminar was exactly that. That a lecturer would come in and take a notion, like continuity or something,
Mhm.
or a more technical notion like homotopy, and just try to see the range of mathematical directions that are connected by it.
Mhm.
For example, I remember doing one such basic notions types seminar, um, using Bernoulli numbers. You know,
Mhm.
how do Bernoulli numbers tie together so many different subjects in mathematics? They do. Um, and the idea is not to give any in the basic notions seminar. The idea was not to give any particular recent theorem. The idea was merely to give an overview, so that there are activities at Harvard which are devoted to giving appropriate overviews that go beyond teaching any particular subject, or giving an account of any recent uh, wonderful result, overviews.
Mhm.
At one point, the Basic Notions seminar began to get too hard, or at least for a while there. Maybe it's gone back.
Yep.
Uh, and so the graduate students started something that they called the Trivial Notions seminar, which was meant to be the Basic Notions seminar correctly calibrated, so to speak.
Mhm. Yeah. So that's really a very sparking point part of the Harvard's curriculum. So I would say that a lot of the courses there really teaches students to implement these knowledge into real life, so it's applicable in real life, basically in our current society, really. And so I also heard about there's a really extremely hard course at Harvard, which is Math 55.
Yeah, yeah.
And, they were saying that that is a course for geniuses. A lot of people that I know, it's super difficult.
Very difficult. Yeah. Yeah, there is. It is.
Yeah,
But
so
they're also easy courses.
mhm. I mean, Harvard's courses are, of course, really, really difficult, but out of so many difficult courses, that is the most difficult course ever.
Yeah, it covers a broad spectrum of even of subjects, but of topics. Um, yeah, it is.
Yeah, and did you teach Math 55 before?
I taught it.
Yeah. So at Harvard University, I would say that you taught there for more than 10 years, of course. For
Well, uh, yeah, more than 10 years. In fact, when I first came,
Mhm.
when was your grandparents, your grandmother born?
Oh, I think I forgot her birthday, but it's not like I don't know. My grandma's like currently around 70. I think she is around that age.
Okay.
So
Okay, I came when your grandmother was 7 years old.
wow, crazy.
Yeah,
That is a long time.
a
That
long
is
time. Yeah.
wow. So you are like decades at Harvard, basically.
Well, more than 6 decades.
Oh, for sure. Yeah, because most professors I know they talk about how they taught there for 10 to 20 years, and I thought that was just wow, a long time, but you stayed there for I don't know, 70 years, so that's a very close connection to the Harvard community.
Yeah. 1959 is when I came.
Yeah. Calculation algebra. Yeah, so, are people really casual or more serious at Harvard College? Are they
Oh, you mean over this span?
yeah, over your span of years,
Oh,
what
better,
changes did you
much
observe?
better. The students are much better
Oh,
now.
really?
Oh,
Over the
much
span
better.
of years? Oh,
Yeah,
okay.
yeah.
So, is it due to a more strict, application process for Harvard? Like, there's better people
Well,
here?
I think I think one of the things that when I say students, I meant mathematics students, but I'm sure other departments as well. But with mathematics, the high schools became really good.
Mhm,
And there are summer math programs that all of the high school um, students who are interested in math very often go to, and they take, um, uh, well, they do sort of perhaps elementary, but probably interesting and important research, uh, tiny research projects, even uh, in high school, where this never happened in the early days. In the early days, we just have better students now. I mean, certainly very much more prepared students.
mhm. Yeah, for sure. I know right now a lot of people like there's lots of different programs, even like summer schools. So I think people are now more hardworking. I'm
Summer schools, yeah, yeah.
yeah, I totally agree. And over your years at Harvard, which course was the most enjoyable to teach for you?
Oh, that no, there was so many. I mean, I can't make a choice of one or the other. I mean, I've taught in a lot of different subjects too. I began teaching largely in uh, topological, geometric subjects, let me say.
Mhm.
And now and then algebraic subjects, and now tends to be number theory.
Oh, yeah.
Also, I'm I have a position that is not only in the math department. It's a position which suggests that I teach, co-teach in other departments as well,
Mhm.
and I do that, and I've done that for decades too.
Oh, so which departments do you teach at currently?
Well, I used to, for example, I would teach, at least give seminars in the history of science department.
Mhm.
And now it's in the philosophy department.
Wow. Mhm. So it's really diverse. I mean, you can
Yeah.
always
Yeah.
yeah. So how do you incorporate mathematical ideas to your
Oh,
philosophy
yeah. Oh,
department?
yeah. Well, I always co-teach with someone. One semester, I co-taught a course in the law school with
Mm,
uh, a law professor, Noah Feldman, and the title of it was The Nature of Evidence.
okay.
So you can imagine there's evidence in law, there's evidence in mathematics, there are evidence in other fields. We got people in other fields to come and just give the students a sense of what it means to have uh, a consensual understanding in their field that progress has been made due to evidence acquired, and what does it mean to have evidence in their field. And it turns out that it's fascinating. It's different fields have different concepts of evidence appropriate to regard as producing um, con- a consensual progress in their field.
Yeah, for sure. And I think there's always do you think that math is really the fundamentals of everything in our society, of how our current society operates, how it's even incorporated into everything as a basis?
Yeah.
Mhm. So during your free times, do you, read any novels or
I read lots of novels.
yeah, do you have any recommendations? I think that
Oh, no, I'll hold off on recommendations. I mean, uh, at the moment, I'm actually reading and uh, I mean, I don't think this would be helpful here. I've been reading Proust.
oh,
So,
Marcel Proust,
yeah,
In Search of Lost Time.
yeah, exactly.
It's a huge volume. I think I only read a little bit of the first volume, but I think as a French writer, it's just a very, very beautiful written piece. It's like, I always wish that I knew if I were to know French, then I could actually maybe sense the
Oh,
significance.
yeah, yeah, yeah.
Mhm.
No, it's wonderful.
Yeah, for sure. What's your favorite part of that novel? Because I think that some of my listeners, they might like that novel or something.
Uh, well, to be clear, actually, I too had only read the first part, Swans Way,
Mhm.
years, and now I'm reading the very end.
Oh, okay. Interesting.
And I had read the middle as well, but I'd read Swans Way quite a number of times. I loved it. Uh, I tried to well, I'd be going into too much detail for this this little conversation for this conversation. But anyway, I loved it.
Yeah, for sure. It's great. And so I can tell that you really like detailed books about very descriptive and with imagery. It's probably it
Yeah,
seems like you're really into this
yeah,
description
yeah,
too.
yeah.
Um, yeah, and do you have one last little tip for how high school students could maybe for people especially who aren't really interested in math and they want help because currently I am tutoring kids, maybe my peers at school as well. um, what what do you think is a way in order to help them really get interested and really develop their skills?
Well, develop their skills is one thing, uh, but there is there is one book that I think helps a lot. It may not get one into the type of mathematics that you teach your students, but it is a wonderful book. It's by Tobias Danzig, and it's called Number, the
Mm,
Language of Science.
mm, sounds really interesting.
And it's comprehensible to absolutely anyone. So you can give it to any person you meet on the street and say, read this book, and it will very likely uh, grab them, no matter where they come from, what they know, what they don't know. When my father was in his mid 70s, and he had two sons who were both mathematicians,
Hmm.
but only in his mid 70s did he think he wanted to really learn mathematics.
Oh.
And I gave him that book, and it inspired him. I mean, he really, uh, first, he wrote marginal notes that were dense in the margins of the book,
Mhm.
and uh, it uh, it opened up the world of mathematics to him. Anyway, but that may not be that appealing to very young people, but it's certainly appealing to certainly was appealing to my father.
Yeah, for sure, and I agree that maybe I should probably advertise it to my whole school and see if they like it, maybe a
See if they
permanent.
like it. See if they like it. They will certainly comprehend it. There is no one who will not understand it as it opens, certainly, and there's no one who won't learn something from it.
Mhm, for
As
sure.
as I read it again just recently, I realized, yeah, I'm still learning from that book.
Yeah, and I think that maybe reading it many times really work as well. You can
Yeah,
always
yeah.
take in new ideas and observations.
Mhm. I mean, it gives the history of number, really.
Yeah, for sure, and thank you so much for
Sure.
responding to my questions.